Hello friends, welcome to FAQ Room. Today I am going to ask some questions on computer science and engineering to Mr. Clara. Hi Clara, how are you?
Hi Flora, I am fine here. How are you? Hope you are doing well. I will explain and give proper answers to all your questions. So let us start today's session.
What is system analysis and system design?
System analysis and system design are two stages of the software development lifecycle. System analysis is a process of collecting and analyzing the requirements of the system, whereas system design is a process of creating a design for the system to meet the requirements. Both are important stages as it helps to create an effective system with all the features and functions.
What is system analysis?
System analysis is a process of understanding the system requirements and its environment. It is one of the initial stages of the software development lifecycle. System analysis is the process of breaking the system down into its individual components and understanding how each component interacts with the other components to accomplish the system's overall goal. In this process, the analyst collects the requirements of the system and documents them.
What is system design?
System design is the process of creating a design for the system to meet the requirements. System design is the process of designing the architecture, components, modules, interfaces, and data for a system to satisfy the specified requirements. It involves the design of the system architecture, components, modules, interfaces, and data.
What is the design and analysis of algorithms?
Design and analysis of algorithms, DAA refers to the design and analysis of algorithms. It helps you in analyzing the solution before coding. You can find out the space and time complexity through the documentation and algorithms. Algorithms and designs give a clear picture of the code you will write to solve the problem.
What is an algorithm?
An algorithm is a sequence of steps to solve a problem. Design and analysis of algorithm is very important for designing algorithm to solve different types of problems in the branch of computer science and information technology.
What is a compiler?
A compiler is a computer program which helps you transform source code written in a high-level language into low-level machine language. It translates the code written in one programming language to some other language without changing the meaning of the code. The compiler also makes the end code efficient, which is optimized for execution time and memory space. The compiling process includes basic translation mechanisms and error detection. The compiler process goes through lexical, syntax, and semantic analysis at the front end and code generation and optimization at the back end.
What is compiler design?
Compiler design is the structure and set of principles that guide the translation, analysis, and optimization process of a compiler. A compiler is computer software that transforms program source code which is written in a high-level language into low-level machine code. It essentially translates the code written in one programming language to another language without changing the logic of the code. The compiler also makes the code output efficient and optimized for execution time and memory space. The compiling process has basic translation mechanisms and error detection. It can't compile code if there is an error. The compiler process runs through syntax, lexical, and semantic analysis in the front end and generates optimized code in the back end. When executing, the compiler first analyzes all the language statements one after the other syntactically and then, if it's successful, builds the output code, making sure that statements that refer to other statements are referred to appropriately. Traditionally, the output code is called object code.
What is data structure and algorithms?
A computer program is a collection of instructions to perform a specific task. For this, a computer program may need to store data, retrieve data, and perform computations on the data. A data structure is a named location that can be used to store and organize data. And an algorithm is a collection of steps to solve a particular problem. Learning data structures and algorithms allow us to write efficient and optimized computer programs.
What is computer architecture and organization?
Computer architecture is a functional description of the design, implementation, and requirements of different components of a computer, while computer organization provides information about the linking of different operational attributes of the computer system.
What is computer architecture?
Computer architecture is a blueprint for design and implementation of a computer system. It refers to the overall design of a computer system, including the hardware and software components that make up the system and how they interact with each other. Computer architecture provides the functional details and behavior of a computer system. It involves the design of the instruction set, the microarchitecture, and the memory hierarchy, as well as the design of the hardware and software components that make up the system. Computer architecture mainly deals with the functional behavior of a computer system and covers the what-to-do part. It gives the functional description of requirements, design, and implementation of the different parts of a computer system. In the designing process of a computer system, the computer architecture is to be defined before the computer organization.
What is computer organization?
Computer organization refers to the way in which the hardware components of a computer system are arranged and interconnected. It implements the provided computer architecture and covers the how-to-do part. Computer organization is to be defined after the decision of the computer architecture. It just provides information that how operational attributes of a computer system are linked together and help in realizing the architectural specification of the computer. It involves the design of the interconnections between the various hardware components, as well as the design of the memory and I/O systems.
What is microprocessors and microcontrollers?
Both microprocessors and microcontrollers are types of electronic devices that come in the form of integrated circuits ICs and are used in different modern electronic equipment such as computers, laptops, washing machines, air conditioners, and many other automated electronic gadgets. The primary function of both microprocessors and microcontrollers is to automate the processes.
What is a microprocessor?
As its name implies, it is a processing device that converts data into information based on some sets of instructions. It is a very compact electronic chip due to which it is referred to as the microprocessor. In other words, a processing device implemented on a single chip is called a microprocessor. A microprocessor is the most crucial component of a computer or any other computing device, because it is entirely responsible for processing data based on instructions to produce information. In microcomputers, the microprocessor is used as the CPU central processing unit. A typical microprocessor consists of two major parts, namely ALU arithmetic logic unit and CU control unit. Intel 8085 or 8086 processing chips are the examples of microprocessors. Modern microprocessors consist of a small memory unit, cache memory, in addition to the ALU and CU. Nowadays, microprocessors are being widely used in several applications such as desktop publishing, power plant control, multimeters, medical instruments, etc.
What is a microcontroller?
A microcontroller is an electronic system which consists of a processing element, a small memory RAM, ROM, EPROM, I/O ports, etc. on a single chip. Therefore, a microcontroller is a tiny resemblance of a microcomputer. It is a quite small and low-cost electronic device which is used in several electronic appliances as the main functioning device. In electronic systems such washing machines, air conditioners, refrigerators, etc., microcontrollers are used to automate the operation of the device based on users' instructions. Hence, a microcontroller is the backbone of all embedded systems like microwave oven, washing machine, smart refrigerators, etc. Microprocessors find their application in light sensing and controlling devices, temperature sensing and controlling devices, fire detection and other safety devices, smart measuring instruments, etc.
What is software testing and quality assurance in computer engineering?
Software testing and quality assurance (QA) are two related but distinct processes within the software development life cycle. Software testing is the process of identifying and verifying that software applications or programs will meet the user's requirements, and quality assurance is the process of ensuring that the software meets the set standards of quality. Both processes are essential for delivering a high-quality product. Software testing focuses on the evaluation of a product or service to determine if it meets its design specifications and meets the user's needs. Quality assurance is a continuous process that begins during the planning stages of a product or service and continues through the development, testing, and deployment of the product or service. Software testing involves creating test plans, writing test cases, and performing manual and automated tests to ensure the product meets its specified requirements.
What is quality assurance?
Quality assurance (QA) is the process of ensuring that the software product meets the specified quality standards. It is a continuous process that involves planning, designing, developing, and testing the software. QA focuses on the quality of the software product and is done by software engineers and developers. Its primary goal is to ensure that the software meets the customer's requirements and is of high quality. QA is a process-oriented approach that involves implementing best practices and process improvements to ensure the quality of the software. It includes activities such as requirements gathering, design review, code review, unit testing, system testing, integration testing, and regression testing.
What is electrical technology?
Electrical technology is the study of machines, equipment, technology and systems that conduct electrical charges and produce electricity. Professionals in the electrical technology field maintain electric voltage systems and their individual parts, such as heaters, motors, circuits and generators. They also often install wiring systems and circuit boards. Electrical technology also comprises the study of electrical distribution systems that control the amount of energy an appliance, such as an energy converter or control system, receives. Here are several duties that professionals within the electrical technology field often perform: diagnosing wiring issues, consulting with customers on electrical problems, installing new wiring systems, updating electrical systems, maintaining circuit boards, using specialized electrical equipment.
What is mobile computing?
The term mobile computing refers to a group of IT tools, services, and operational methods that allow users to access computing, data, and related resources and capabilities while on the go. In human-computer interaction, known as mobile computing, a computer is expected to be carried around while being used, allowing for data, speech, and video transmission. Mobile hardware, mobile software, and mobile communication are all components of mobile computing. Mobile computing technology is widely used today. It is used in a variety of specialized vertical sectors in addition to the commercial and consumer markets, as well as the industrial and entertainment industries. What is a mobile computing device (MCD)? Any device built employing mobile parts, such as mobile hardware and software, is referred to as a mobile computing device. Portable devices that can function like a standard computer device in terms of operation, execution, and provision of services and applications are known as mobile computing devices. For example, mobile phones are telephones that can make long-distance calls using cellular networking technology, or smart cards that are often used for payments, travel, and security area access but can run many applications that could be examples of MCDs.
What is software and types of software with examples?
Software is a set of instructions, data, or programs used to operate computers and execute specific tasks. It is the opposite of hardware, which describes the physical aspects of a computer. Software is a generic term used to refer to applications, scripts, and programs that run on a device. It can be thought of as the variable part of a computer, while hardware is the invariable part. The two main categories of software are application software and system software. An application is software that fulfills a specific need or performs tasks. System software is designed to run a computer's hardware and provides a platform for applications to run on top of. Other types of software include programming software, which provides the programming tools software developers need, middleware, which sits between system software and applications, and driver software, which operates computer devices and peripherals. Early software was written for specific computers and sold with the hardware it ran on. In the 1980s, software began to be sold on floppy disks, and later on CDs and DVDs. Today, most software is purchased and directly downloaded over the internet. Software can be found on vendor websites or application service provider websites. Examples and types of software. Among the various categories of software, the most common types include the following. Application software. The most common type of software, application software, is a computer software package that performs a specific function for a user, or in some cases, for another application. An application can be self-contained, or it can be a group of programs that run the application for the user. Application software. The most common type of software, application software, is a computer software package that performs a specific function for a user, or in some cases, for another application. An application can be self-contained, or it can be a group of programs that run the application for the user. Examples of modern applications include Office suites, graphics software, databases and database management programs, web browsers, word processors, software development tools, image editors, and communication platforms. System software. These software programs are designed to run a computer's application programs and hardware. System software coordinates the activities and functions of the hardware and software. In addition, it controls the operations of the computer hardware and provides an environment or platform for all the other types of software to work in. The OS is the best example of system software. It manages all the other computer programs. Other examples of system software include the firmware, computer language translators and system utilities. Driver software, also known as device drivers, this software is often considered a type of system software. Device drivers control the devices and peripherals connected to a computer, enabling them to perform their specific tasks. Every device that is connected to a computer needs at least one device driver to function. Examples include software that comes with any non-standard hardware, including special game controllers, as well as the software that enables standard hardware, such as USB storage devices, keyboards, headphones and printers. Middleware. The term middleware describes software that mediates between application and system software or between two different kinds of application software. For example, middleware enables Microsoft Windows to talk to Excel and Word. It is also used to send a remote work request from an application in a computer that has one kind of OS to an application in a computer with a different OS. It also enables newer applications to work with legacy ones. Programming software. Computer programmers use programming software to write code. Programming software and programming tools enable developers to develop, write, test and debug other software programs. Examples of programming software include assemblers, compilers, debuggers and interpreters.
What is programming softwares?
Programming software is a software which helps the programmer in developing other software. Compilers, assemblers, debuggers, interpreters etc. are examples of programming software. Integrated development environments (IDEs) are combinations of all these software.
What are the best programming languages to learn in 2023?
What coding and programming language should I learn? JavaScript and Python, two of the most popular languages in the startup industry, are in high demand. Most startups use Python-based backend frameworks such as Django Python, Flask Python, and Node.js JavaScript. These languages are also considered to be the best programming languages to learn for beginners. Below is a list of the most popular and best programming languages that will be in demand in 2023. 1. JavaScript. 2. Python. 3. Go. 4. Java. 5. Kotlin. 6. PHP. 7. C. 8. Swift. 9. R10. Ruby. 11. C and C++. 12. MATLAB. 13. TypeScript. 14. Scala. 15. SQL. 16. HTML. 17. CSS. 18. NoSQL. 19. Rust. 20. Perl.
What is internal memory and how is it different from external memory?
Computer memory is generally classified as either internal or external memory. Internal memory, also called main or primary memory, refers to memory that stores small amounts of data that can be accessed quickly while the computer is running. External memory, also called secondary memory, refers to a storage device that can retain or store data persistently. They could be embedded or removable storage devices. Examples include hard disk or solid-state drives, USB flash drives, and compact disks.
What are the types of internal memory?
There are basically two kinds of internal memory, ROM and RAM. ROM stands for read-only memory. It is non-volatile, which means it can retain data even without power. It is used mainly to start or boot up a computer. Once the operating system is loaded, the computer uses RAM, which stands for random access memory, which temporarily stores data while the central processing unit CPU is executing other tasks. With more RAM on the computer, the less the CPU has to read data from the external or secondary memory storage device, allowing the computer to run faster. RAM is fast, but it is volatile, which means it will not retain data if there is no power. It is therefore important to save data to the storage device before the system is turned off.
What is RAM and ROM?
RAM, which stands for Random Access Memory, and ROM, which stands for Read-Only Memory, are both present in your computer. RAM is volatile memory that temporarily stores the files you are working on. ROM is non-volatile memory that permanently stores instructions for your computer. Uses of ROM and RAM. A ROM chip is used primarily in the startup process of a computer, whereas a RAM chip is used in the normal operations after the operating system is loaded. For example, a ROM chip is used to store the BIOS program on the motherboard. A RAM chip temporarily stores files in use on a computer, like a document you're writing, an image you're editing, or data for a game you're playing. Storage capabilities of ROM and RAM. A ROM chip is a non-volatile storage medium, which means it does not require a constant source of power to retain the information stored on it. By contrast, a RAM chip is volatile, which means it loses any information it is holding when the power is turned off. Essentially, ROM is used for permanent storage, and RAM is for temporary storage. Storage capacity of ROM and RAM. A ROM chip stores several megabytes of data, usually 4 to 8 megabytes per chip, whereas a RAM chip can store multiple gigabytes of data, ranging from 1 to 256 gigabytes per chip. Computer ROM. An example of ROM is the computer BIOS, a programmable read-only memory chip that stores the programming needed to begin the initial computer startup process. Using a non-volatile storage medium is the only way to begin this process for computers and other devices. ROM chips were also used in gaming system cartridges, like the original Nintendo, Game Boy, Sega Genesis, and others. The oldest ROM-type storage medium can be dated back to 1932 with drum memory. ROM-type storage is still used today. Computer RAM. RAM chips are used in computers and other devices to store temporary information produced by programs quickly. RAM is one of the fastest types of memory, allowing it to switch quickly between tasks. For example, the internet browser you are using to read this page is loaded into RAM and is running from it. We can vaguely split the types of random access memory into two categories: static random access memory, dynamic random access memory.
What are the examples of ROM?
So, ROM is a programmable logic device (PLD). A simple example of ROM is the cartridge used in video game consoles that allows the system to run many games. The data which is stored permanently on personal computers and other electronic devices like smartphones, tablets, TV, AC, etc. is also an example of ROM.
What are the examples of RAM?
Today, the most common type of RAM is DDR-SDRAM, or Double Data Rate Synchronous Dynamic Random Access Memory, and there are various iterations, including DDR2, DDR3, DDR4, and even DDR5. DDR double data rate allows simultaneous multiple file transfers.
What is RAM and its example?
RAM random access memory is the hardware in a computing device where the operating system OS, application programs, and data in current use are kept so they can be quickly reached by the device's processor. RAM is the main memory in a computer. It is also called read-write memory, or the main memory, or the primary memory. The programs and data that the CPU requires during the execution of a program are stored in this memory. It is a volatile memory as the data is lost when the power is turned off. What are examples of RAM devices? Random access devices include hard drives, CD compact disc writers, and DVD digital versatile disk RAM random access memory devices. The hard drive typically has a storage capacity of 20 GB GB and a data transfer rate of over 10 MB MB per second.
What are the types of RAM?
There are two main types of RAM, dynamic RAM DRAM and static RAM SRAM. DRAM, pronounced DRAM, is widely used as a computer's main memory. Each DRAM memory cell is made up of a transistor and a capacitor within an integrated circuit, and a data bit is stored in the capacitor. Since transistors always leak a small amount, the capacitors will slowly discharge, causing information stored in it to drain. Hence, DRAM has to be refreshed given a new electronic charge every few milliseconds to retain data. SRAM, pronounced ESRAM, is made up of 4 to 6 transistors. It keeps data in the memory as long as power is supplied to the system, unlike DRAM, which has to be refreshed periodically. As such, SRAM is faster but also more expensive, making DRAM the more prevalent memory in computer systems.
What are the common types of DRAM?
Synchronous DRAM SDRAM synchronizes the memory speed with CPU clock speed so that the memory controller knows the exact clock cycle when the requested data will be ready. This allows the CPU to perform more instructions at a given time. Typical SDRAM transfers data at speeds up to 133 MHz. Rambus DRAM takes its name after the company that made it, Rambus. It was popular in the early 2000s and was mainly used for video game devices and graphics cards, with transfer speeds up to 1 GHz. Double data rate SDRAM DDR-SDRAM is a type of synchronous memory that nearly doubles the bandwidth of a single data rate SDR-SDRAM running at the same clock frequency by employing a method called double pumping, which allows transfer of data on both the rising and falling edges of the clock signal without any increase in clock frequency. DDR1 SDRAM has been succeeded by DDR2, DDR3, and most recently, DDR4 SDRAM. Although operating on the same principles, the modules are not backward compatible. Each generation delivers higher transfer rates and faster performance. The latest DDR4 modules, for example, feature fast transfer rates at 2133, 2426.66 and even 3200 metric tons s.
What is a central processing unit CPU?
The central processing unit CPU is the primary component of a computer that acts as its control center. The CPU, also referred to as the central or main processor, is a complex set of electronic circuitry that runs the machine's operating system and apps.
What is hard disk? Explain.
A computer hard drive or a hard disk or HDD is one kind of technology that stores the operating system, applications, and data files such as documents, pictures and music that your computer uses. The rest of the components in your computer work together to show you the applications and files stored on your hard drive.
What is motherboard in a computer?
A motherboard is the main printed circuit board PCB in a computer. The motherboard is a computer's central communications backbone connectivity point, through which all components and external peripherals connect. Motherboards can be found in virtually all computers, especially desktop and laptop PCs.
What is motherboard and its function?
A computer's motherboard is typically the largest printed circuit board in a machine's chassis. It distributes electricity and facilitates communication between and to the central processing unit CPU, random access memory RAM, and any other component of the computer's hardware.
What is the processor in a computer?
The processor is a circuit that performs all of the calculations needed to run the computer. Modern computers often have more than one processor. For example, a gaming computer typically has both a central processing unit CPU and a graphics processing unit GPU.
What is a graphics card used for?
GPUs can be used for video editing, 3D graphics rendering, and much more. With a high processing throughput, GPUs can process more data than their central processing unit CPU counterparts, making them uniquely suited for highly demanding tasks such as machine learning and cryptocurrency mining. What is webcam? With an example of webcam in computer. A webcam is a camera that connects to a computer. It captures either still pictures or motion video, and with the aid of software, can transmit its video on the internet in real time.
What is the main use of webcam?
A webcam is a video camera which is designed to record or stream to a computer or computer network. They are primarily used in video telephony, live streaming and social media, and security.
What is the computer keyboard?
A computer keyboard is an input device used to enter characters and functions into the computer system by pressing buttons, or keys. It is the primary device used to enter text. A keyboard typically contains keys for individual letters, numbers and special characters, as well as keys for specific functions.
What is a computer mouse?
A computer mouse, plural mice, also mouses, is a handheld pointing device that detects two-dimensional motion relative to a surface. This motion is typically translated into the motion of a pointer on a display, which allows a smooth control of the graphical user interface of a computer.
What is VM and how do virtual machines work?
Virtual machines are made possible through virtualization technology. Virtualization uses software to simulate virtual hardware that allows multiple VMs to run on a single machine. The physical machine is known as the host while the VMs running on it are called guests.
What is high-level language example?
A high-level language HLL is a programming language, such as C, Fortran, or Pascal, that allows a programmer to develop programs that are independent of the type of machine they are running on. All these languages are classified as high-level because they are more comparable languages than machine languages. Examples of high-level programming languages in active use today include Python, JavaScript, Visual Basic, Delphi, Perl, PHP, ECMAScript, Ruby, C, Java and many others. The terms high-level and low-level are inherently relative.
What is a low-level language with example?
A low-level language is a programming language that provides little or no abstraction of programming concepts and is very close to writing actual machine instructions. Two examples of low-level languages are assembly and machine code.
What is the main difference between high-level and low-level language?
The main difference between high-level language and low-level language is that programmers can easily understand or interpret or compile the high-level language in comparison of machine. On the other hand, machine can easily understand the low-level language in comparison of human beings. High-level languages require the use of a compiler or an interpreter for their translation into the machine code. Low-level language requires an assembler for directly translating the instructions of the machine language. These languages have a very low memory efficiency.
What is compiler?
Compiler. A compiler is a computer program that reads a program written in a high-level language such as Fortran, PLI, COBOL, etc. It can translate it into the same program in a low-level language including machine language. The compiler also finds out the various errors encountered during the compilation of a program. The compiler converts high-level language into low-level language using various phases. A character stream inputted by the customer goes through multiple stages of compilation which at last will provide target language. Advantages of compiler. There are various advantages of the compiler which are as follows: a compiler translates a program in a single run. It consumes less time. CPU utilization is more. Both syntactic and semantic errors can be checked concurrently. It is easily supported by many high-level languages like C, C++, Java, etc.
What is interpreter?
Interpreter. An interpreter is a program that executes the programming code directly instead of just translating it into another format. It translates and executes programming language statements one by one. An interpreter takes less time to interpret a source program as distinguished by a compiler. Advantages of interpreter. There are various advantages of the interpreter which are as follows: an interpreter translates the program line by line. The interpreter is smaller in size. It is flexible. Error localization is easier. The interpreter facilitates the implementation of computer programming language constructs.
What is an assembler in computer?
The assembler is a software that converts an assembly language code to machine code. It takes basic computer commands and converts them into binary code that computer's processor can use to perform its basic operations. Assembler is a program for converting instructions written in low-level assembly code into relocatable machine code and generating a long information for the loader. It generates instructions by evaluating the mnemonic symbols in operation field and find the value of symbol and literals to produce machine code.
What is assembler and compiler in computer?
The difference between compiler and assembler is that a compiler is used to convert high-level programming language code into machine language code. On the other hand, an assembler converts assembly-level language code into machine language code. Both these terms are relevant in context to program execution.
What is front-end languages and back-end languages?
Front-end languages versus back-end languages. Front-end languages are called client-side languages, which are used to create virtual and interactive website elements that users can see. The front-end languages include HTML, CSS, and JavaScript. Back-end languages are known as server-side languages. They create logic and functionality behind the scenes of the website, like processing, storing and managing the user's account and authentication. Python, Ruby, and Java are some of the back-end languages.
What are interpreted languages versus compiled languages?
Interpreted languages versus compiled languages. The interpreter directly executes and reads the interpreted code line by line without compiling it into machine code. It can be executed immediately without requiring separate compilation steps, such as Python, Ruby, and JavaScript. In contrast, the compiler first translates the compiled languages into machine code, further converts the human-readable code into a structure that computers can execute. Languages like C, C++, and Java fall into this category.
What are high-level languages versus low-level languages with examples?
High-level languages versus low-level languages. High-level languages are easy to read and write since they are understandable. Developers can write code at a higher level of abstraction without worrying about the underlying hardware or operating system, as it is close to natural languages. They have built-in libraries and frameworks to simplify ordinary programming tasks like managing data structures or executing calculations. Examples of high-level languages are Python, Java, or Ruby. On the other hand, low-level languages are much more complex to understand and write. The code written in low languages is very efficient and directly manipulates the hardware and memory of the computer. Yet the developer needs to rely on manual efforts and understanding. Assembly language and C are examples of this type of low-level language.
What are the most popular and best programming languages that will be in demand in 2023?
Below is a list of the most popular and best programming languages that will be in demand in 2023. 1. JavaScript 2. Python 3. Go 4. Java 5. Kotlin 6. PHP 7. C8. Swift 9. R10. Ruby 11, C and C++ 12, MATLAB 13, TypeScript 14, Scala 15, SQL 16, HTML 17, CSS 18, NoSQL 19, Rust 20, Perl. 1. JavaScript. JavaScript is a high-level programming language that is one of the core technologies of the World Wide Web. It is used as a client-side programming language by 97.8% of all websites. JavaScript was originally used only to develop web browsers, but they are now used for server-side website deployments and non-web browser applications as well. JavaScript was created in 1995 and was initially known as LiveScript. However, Java was a very popular language at that time, so it was advertised as a younger brother of Java. As it evolved over time, JavaScript became a fully independent language. Nowadays, JavaScript is often confused with Java, and although there are some similarities between them, the two languages are distinct. JavaScript is the most popular programming language in the world and is in high demand among various organizations. The average Java developer earns around $112,152 each year. 2. Python. Python is one of the most popular programming languages today and is easy for beginners to learn because of its readability. It is a free, open-source programming language with extensive support modules and community development, easy integration with web services, user-friendly data structures, and GUI-based desktop applications. It is a popular programming language for machine learning and deep learning applications. Python is used to develop 2D imaging and 3D animation packages like Blender, Inkscape, and Autodesk. It has also been used to create popular video games, including Civilization 4, Vegas Strike, and Toontown. Python is used for scientific and computational applications like FreeCAD and Abacus and by popular websites like YouTube, Quora, Pinterest, and Instagram. Python developers earn average annual salaries of about $109,092. 3. Java. Java is one of the most popular programming languages used today. Owned by Oracle Corporation, this general-purpose programming language with its object-oriented structure has become a standard for applications that can be used regardless of platform, example, Mac, Windows, Android, iOS, etc. Because of its write once, run anywhere where capabilities. As a result, Java is recognized for its portability across platforms, from mainframe data centers to smartphones. Today there are more than 3 billion devices running applications built with Java. Java is widely used in web and application development as well as big data. Java is also used on the backend of several popular websites, including Google, Amazon, Twitter, and YouTube. It is also extensively used in hundreds of applications. New Java frameworks like Spring, Struts, and Hibernate are also very popular. With millions of Java developers worldwide, there are hundreds of ways to learn Java. Also, Java programmers have an extensive online community and support each other to solve problems. Java is a more complex language to learn, but experienced developers with Java coding skills are in high demand. The average Java developer earns around $109,225 each year. 4. C. Developed by Microsoft, C rose to fame in the 2000s for supporting the concepts of object-oriented programming. It is one of the most used programming languages for the .NET framework. Anders Hallsberg, the creator of C, says the language is more like C++ than Java. C is best suited for applications on Windows, Android, and iOS, as it takes the help of the Integrated Development Environment product, Microsoft Visual C++. C is used on the backend of several popular websites like Bing, Dell, Visual Studio, and MarketWatch. C developers earn around $111,760 per year. 5. C and C++. C is probably the oldest and popular programming language and is the root of other programming languages such as C, Java, and JavaScript. C++ is an enhanced version of C. Many developers today skip learning C on its own, while others think learning C first provides a valuable foundation for C++ development. Both languages are widely used in computer science and programming. C and C++ developers can make use of compilers for a wide variety of platforms, making applications developed in these languages largely transportable. Both C and C++ are considered high-performance languages. As such, they are widely used in developing applications where performance is a critical issue, such as client-server applications, commercial products like Firefox and Adobe, and video games. C and C++ developers earn an average of $118,366 each year. 6. MATLAB. MATLAB is a proprietary programming language owned by MathWorks and originally released in the mid-1980s. It is built specifically for use by scientists and engineers. Programmers use MATLAB to build machine learning and deep learning applications. MATLAB-based programs enable users to analyze data, create algorithms, process images, and verify research. Generally, MATLAB is easier to learn than other programming languages on our list. MathWorks website has an extensive section dedicated to answering questions about MATLAB. The average MATLAB developer takes home an average salary of $100,760 each year. 7. SQL. SQL is a standard database query language. It is used to access and manipulate data in databases. SQL is a declarative language that specifies the desired results, but not the steps to achieve those results. SQL is a powerful tool for accessing and manipulating data, and it is the world's most widely used database query language. Benefits of SQL. SQL is a standard database query language that enables users to manipulate and query data in a database quickly. SQL is widely used in many applications and environments, such as web applications, data warehouses, and e-commerce applications. SQL provides many benefits over other database query languages, such as improved performance, better data integrity, and more accessible data manipulation. Cons of SQL. If you are unfamiliar with programming or database concepts, SQL can be challenging to learn. SQL can be slow compared to other languages, mainly when working with large databases. And SQL is not well suited for certain types of tasks, such as complex mathematical calculations or machine learning. 8. HTML. HTML hypertext markup language is the standard language for creating web pages and applications. HTML is used to create web pages. You can use HTML to add images, links, and other types of content to your web page. HTML is a simple programming language. You don't need to know much about it to create a basic web page. Images and other objects, such as interactive forms, can be embedded within the produced page using HTML structures. It enables the creation of structured documents by indicating structural semantics for text elements including as headings, paragraphs, lists, links, quotations, and other objects. HTML elements are delineated by tags, which are written in angle brackets. Benefits of HTML. Benefits of using HTML include creating well-structured, standards-compliant web pages that are easy to maintain and update. HTML is also easy to learn and is a great starting point for those new to web development. HTML is used to structure and present content on the web and is typically used alongside CSS and JavaScript. Additionally, HTML5 provides better multimedia and interactive content support, making it a powerful tool for creating engaging web experiences. HTML5 is the latest version and includes new features like video and audio elements, local storage, and 2D, 3D graphics. HTML5 is designed to be more user-friendly and efficient than previous versions of HTML. Cons of HTML. A few potential drawbacks exist to using HTML as a web development language. First, because HTML is a markup language, it is not as expressive as a programming language like JavaScript or PHP, which means that complex web applications or pages can be more challenging to develop in HTML. Additionally, HTML is not a very secure language, so web developers must carefully encode any user input to prevent security vulnerabilities properly. Finally, HTML can be somewhat challenging to learn for newcomers, as it has a lot of different elements and syntax rules. Thank you for watching special FAQ room session on engineering disciplines for career guidance. Please watch, like, comment, share, subscribe and follow the AI YouTube channel. Hi, I am Clara. I will give all answers to Flora S collective frequently asked questions in every session, whatever the questions related to discipline of engineering. Viewers also contribute to ask questions and may provide answers in the comments.
Hi, I am Flora collecting questions from various disciplines of engineering and passes to Clara to provide proper answers. Viewers also requested to engage to provide much better answer to the questions in comments for review and feedback.
Thank you for watching this session. Please check and watch next season when published. Click the button for bell icon for notifications. Please like, comment, share and subscribe my AI channel through which the FAQ Room is publishing. Please follow and support my channel. AI YouTube channel viewers also requested to engage to provide much better answer to the questions and comments for review and feedback of sessions, and viewers also requested to contribute to ask questions and may provide answers in the comments box. Thanks for Clara and Flora. Keep watching. Thank you very much. FAQ Room Sessions AI YouTube channel.